The following organizations have provided the funding for this Into the Outdoors television series.
Okay, you can take the controls from now on. I've got to videotape this. See that down there? That's a moraine. It was formed by glaciers over 13,000 years ago. What? Why should you care now? Wow, because our landscapes and soils here in Wisconsin affect everything. From farming, to forests, to lakes, to rivers, even to the waterway drains. And that's why we need to discover the mysteries of glaciers and how they shape the land here in Wisconsin. As we trek the Ice Age Trail, here, into the outdoors.
Hey, hey, hey! Do you hear the call? Yeah! Into the outdoors! Chores are done, let's have some fun! There's so much to do and see! And the outdoors is the place to be! Into the outdoors! Come explore with me, it's a philosophy! From far with the fall! And the outdoors really has it all! Into the outdoors! Earth and sky and the wet and wild, jump in and you will see! There's no place that you'd rather be! Into the outdoors!
All right, before we can begin to understand how glaciers shaped our land in Wisconsin, first we need to know a few more things about glaciers. So let's check in with Master Control. Are you down there?
Thanks, Josh. We'll take it from here. So what are glaciers and how are they formed? Basically, they're made up of ice and snow. Lots of ice and snow. Here's how it works.
If climate conditions are just right, snow keeps piling up in layers that get thicker and thicker. This can happen over a really long time across a large area. The key to making glaciers is to have a lot more snow accumulate than the amount that melts and evaporates. Bottom line is you have to have a yearly net gain of snow. Eventually, the layers get so thick and heavy, their weight compresses the lower layers into ice. With enough layers, weight, and time, it makes glacial ice. Ta-da! You have a glacier.
Hold on. That's all pretty neat and stuff, but there's one curious thing that makes glaciers different from a big pile of ice, right?
Oh yeah, and it's that one thing that also makes them shape the land. They move.
This is the really cool part. If the ice becomes thick enough, over 150 feet thick, the ice at the bottom gets so compressed it can begin to flow like a river of ice or taffy. That's when you have a glacier, which can be up to a mile thick.
And what does it take for something to flow? Gravity. Here, let me show you an example.
Let's say that milkshake is our glacier. Some mountain ranges get so much more snow than what can melt, they form alpine glaciers that flow down the mountain valleys. Like that. Sometimes they call them valley glaciers. That one looks more like a Vanilla Valley glacier.
The other type of glacier is the biggie, called a continental glacier.
That's the huge kind. In fact, they're so huge they cover an entire continent. There used to be a lot more continental glaciers way in the past. Today, Greenland and Antarctica are the two giant remaining continental glaciers. Continental glaciers still flow, but mostly they spread out from the regions where the glacier is making the most ice.
Okay, we know how glaciers form and what makes them move. Let's discover next what happens to all that land when all that ice moves. I think this is the switch.
Now our glacier begins to move. The weight of the ice, maybe a mile thick, crushes and reshapes the landscape as it creeps along. But unlike our fake glacier, real ones flow like a river of ice or taffy in irregular lobes. Plus, they don't always flow at the same rate. Sometimes they stall or even retreat. Combine all that with torrents of meltwater pouring off the front, And you have a complex mix of forces that can form some pretty cool glacial features. Glacial scientists who study glaciers can figure out how glacial features were formed. This study is called glacial geomorphology.
Heck, sometimes great chunks of ice get trapped under the glacier in the soils. When the glacier retreats and the ice melts, it can form a lake called a kettle lake.
See how round that lake is? I'm pretty sure that's a kettle lake. Imagine the big chunk of ice that formed that.
Here in Wisconsin, we had many glaciers that moved across the state and retreated back. All this glacial activity started about 2.5 million years ago and ended about 12,000 years ago. During that time, we had 4 major periods of glacial activity that shaped and reshaped our landscape. And when the ice sheets finally retreated, they left behind some really interesting features.
But the best place to explore them while learning about their mysteries is right down there. It's the Ice Age Trail, and that's where we're headed next. We got a list of neat glacial features you can find while hiking along the Ice Age Trail. Hey, just log on to intotheoutdoors.org.
Put on your hiking boots. Next, we're tracking down the first series of Ice Age mysteries along the trail, and you won't believe what we'll find.
Don't go away. There's more Into the Outdoors.
And now back into the outdoors.
So we're here and we need to get to, I don't know, I think we need some help with this. So if you're going on an adventure, you need information. And what better place to get some than the park headquarters? Come on, I'm sure they've got some maps here. So before exploring the South Catamaran State Forest, Josh and I stopped in the headquarters, got our trail maps, plus toured their natural history display. The ranger gave us pointers on what glacial features to look for. He also explained about the Ice Age creatures that inhabited Wisconsin when the glaciers retreated. Back then, mastodons, woolly mammoths, elk, and 500-pound beavers lived here. We also learned about some of the plants and animals we might see today along the trail.
Hey there! Glad you caught up!
Because we're about to explore our first glacial feature here along the Ice Age Trail. Guess what this thing is?
That's not fair! We don't even know what it is!
Okay, so there's 2 ways you can discover stuff about science. You can research it, like online, or ask a scientist or expert, which we're about to do.
We are now officially on the Ice Age Trail.
Cool!
Any idea why they call it that?
Something to do with ice?
Actually, yes. About 13,000 years ago, glaciers came through and formed this area. They formed this ridge and that valley down below.
This glacial feature looks more like a big hill.
Actually, most geologists call this an interlobate moraine, which means 2 lobes, which are 2 giant glaciers, came together and they dumped lots of sediment down here. And that sediment built up, which formed this ridge. So there will be lots of kettles and moraines in this area. And we also might find some other cool features. Let's go check it out.
Look! It's a snake!
That's one of the cool things about walking the Ice Age Trail. You'll find all sorts of wildlife out here. But the important thing is to not touch the wildlife and leave it in its natural habitat. You can take a picture and you can get a good glance at it, but remember to leave them be. And if you don't touch them, they won't hurt you. Come on, guys, let's see what else we can find.
So this trail is really cool with lots of interesting features. But how does it get here? And where does it go?
This trail is a 1,000-mile footpath, and it goes from one side of Wisconsin to the other. And it follows the terminal moraine, which is where the glaciers ended.
How old is it?
This trail started back in 1958, and it isn't particularly owned by anybody. It's a cooperative deal, really. The Ice Age Trail Alliance, National Park Service, and Wisconsin DNR all work together on it.
What's that feature over there? Whoa, that thing's perfectly rounded. It must be a kettle.
That's right, that is a kettle. Imagine this, 13,000 years ago, a glacier came through here. And as it retreated to the north, a huge chunk of ice was left behind. And as it slowly melted over time, it created this kettle. You're really becoming an Ice Age Trail trekker. Let's see what else we can find, guys.
Yep, this is the Ice Age Trail.
This is just one of the ways you can tell, by that sign or by the yellow blazes that you'll find along the path on the trees. Let's go check it out.
Ah, a big old rock. What a nice place to take a rest.
This rock actually has a story, guys.
A story?
Yeah, it was an erratic rock, which means it came here from far away, and it's not native to the area.
Where did it come from?
Northern Canada, actually. It moved hundreds of miles by the glaciers.
Lizzie turned out to be a great trail guide for the day. We learned a lot from her about the formation of glacial features and hiking the Ice Age Trail. But she had to get back to her homework as Josh and I completed our final section of the trail.
Hey, you seem to know a lot about this place before we got here.
Well, what's wrong with a little research before an adventure? I went to the Ice Age Trail website and learned all kinds of cool glacial stuff. Plus, I got some atlases and trail maps.
Ugh, I should remember to do that beforehand, Smarty.
Besides discovering the glacial geology of the trail, it gave us a chance to explore things about biology, like that snake, botany, and, well, just having fun outdoors being a kid.
Exploring the trail, hiking, and camping really gives us time to appreciate nature.
Just look at all these stairs. It really makes you appreciate the hundreds of volunteers who work hard to help maintain the trail.
So I guess in the end, the trail makes us stronger physically. I mean, just look at these legs. Smarter in science and nature, and makes us appreciate all the important people and stuff in life.
Yeah, Lizzie was pretty cool. And in the end, all that makes me appreciate the Ice Age Trail.
Let's get going. I think there are thunderstorms coming. Hi-ho,
Hi-ho, down the Ice Age Trail we go.
Hi-ho, hi-ho, hi-ho. Oh, this is pretty tiring, but really fun.
Yeah, let's keep going. I don't think the bottom's too far away.
Hi-ho,
Hi-ho, down the Ice Age Trail we go.
To discover where you can hike the Ice Age Trail, log on to intotheoutdoors.org.
Stick around. We're about to go work off those granola bars by exploring more of the rugged sections of the Ice Age Trail.
Don't go away. There's more Into the Outdoors.
And now back into the outdoors.
Welcome back to the show, Trailing Ice Age Mysteries. With over 1,000 miles yet to explore, let's send you northward to discover the rugged geology of another section.
So what's your compass say?
I don't know, but that yellow marker says downhill is over there.
Whoa, hi. Be careful because this is a pretty steep terrain. You know, we're located in the Dells of Eau Claire in Marathon County. And this is the section of the Ice Age Trail. So the word dell means a small valley, and it usually has a woods along the side of it. I think this gorge pretty much fits the bill. There's only one difference. This landscape, it doesn't have the kettles or moraines that we've usually been seeing.
These exposed rocks are a lot older too. So if you think back on how glaciers crush terrain and smooth out valleys like this, then why do we have all these angular rocks in this dell? And how are glacial forces involved?
Let's get some help from Mission Control.
Gotcha. Ooh, your signal's pretty weak. Are you in a gorge? Oh, I see. You're in a rocky dell. Switching to satellite view.
All right, let's try to decode what happened here. Oh, we see a huge ridge to the east of you. That's the Hancock Moraine. It marks the front of the glacier at one time.
What's your guess on where that ice front came from to make that moraine? Remember, the front of the ice acted like a conveyor belt.
Right. The lobe of ice came from the east. Now, if the front of it stopped there, how did that glacier help form the dells?
Back to you, Alea. As for your answer, I think you can hear your clue.
What? What'd you say? I can't hear you. There's too much rushing water.
That's it! The torrents of meltwater pouring off the front of the glacier rushed through here. All that water carrying tons of sand helped carve out this gorge and expose all these rocks. So that's how glaciers help form this area. Come on, let's see what we can discover here.
there are some people that have a professional job that's related to the Ice Age Trail. But there are lots more people who volunteer in making these trails nice so everybody can enjoy them.
I mean, it's amazing how many people hike this section of trail just to hike it. And sometimes they appreciate what they have and they may want to get involved to say, hey, how can I help keep it in this condition? Or as we go into different parts of the county and build new trail, you know, they may want to get involved at a level that says, hey, how can I leave a legacy here and get involved in building something new that will be here forever? People who volunteer on this trail as individuals or with groups. As a matter of fact, on this section of trail that we're hiking today, throughout the course of the summer, I've got 3 Boy Scout and Girl Scout projects going to be going on in here.
So it takes all the chapters to work together to make the trail go?
Absolutely. I mean, this is a long trail. There's about 600 miles of trail on the ground right now. We're a little bit over halfway completed. And if we didn't have help from all the way across the state, the trail would never get done.
So how can young people like me get involved?
Probably the easiest way would be go to iceagetrail.org and click on the local chapter of where you live, and you'd be able to plug yourself in that way.
Oh.
You have your GPS handy, right?
Yeah.
Pull it out.
All right.
Check your current location. You see there where it says 4500?
Uh-huh.
This is the exact halfway point between the equator and the North Pole. Whoa. Probably the only place on the Ice Age Trail that crosses this particular spot.
45th parallel.
It's pretty awesome, isn't it?
Yeah. So how come there's not any glacial features here?
Well, this is an outwash plain. The terminal moraine is about a mile to the north of us. That's as far as the glacier got. And then it started to melt, and all of the meltwater came right through this gorge and headed down towards the middle part of the state.
Okay, so you're saying if there was any drumlins or eskers here, they would have all washed away?
They may have, but they would have been here from a previous glaciation period.
For tips on planning your Ice Age Trail expedition, heck, just log on to intotheoutdoors.org.
Okay, stay tuned because next we're going to be exploring a place where the meltwaters went crazy.
Don't go away, there's more. Into the Outdoors.
And now back into the outdoors.
With over 1,000 miles yet to explore along the Ice Age Trail, we can't possibly show you all the neat places to visit.
In fact, if you had years, you still might miss some of the really cool glacial features or interesting landscapes that this trail has to offer.
So, how do you know where to go? What to look for? How to plan your trip?
Mission Control, how about a little help here?
Roger that. I mean, got you covered, Josh.
Rather than hire a guide, most people get the Ice Age Trail Companion Guide. It helps them plan logistics like connecting roads, trailhead access, nearby towns, places to resupply, eat, and lodging. Looks like something for parents to me. Ah, this one's for kids and parents. Then, for the actual hiking details, the Ice Age Trail Atlas has over 100 detailed maps showing parking places, toilets, campgrounds, shelters, camping spots, topography, and other info on what to see and do. Sweet! Hey, hold on, you guys. I'm getting my system overloaded with information. Whoa! It's coming from the iceagetrail.org website. Look at it all. Maps, trail conditions, rules, overnight options. Oh, there's so much here.
Now that's what I call an Ice Age information jackpot. Oh, wait, we got something else coming in.
Okay, so you've already learned about glaciers in Wisconsin and how they form glacial features like drumlins, eskers, kettles, and moraines. Those big things. But now, you see, they're made from deposits, which are like sand and gravel. And this right here, I didn't just lay an egg. This is a glacial feature. Now, the cool thing about this is that it's a mystery, made right here in this very area. So the answer is right in here. Let's go.
So Aaliyah, here this tells a story of Interstate Park. This is glacial meltwater coming through what may have been the glacial St. Croix River. So this is long after the glaciers melted away to the north. All this meltwater is coming down through here. That island there, perhaps Eagle Peak here at Interstate Park.
I get how all the water is coming down, but what is this big swirly thing right here?
That swirly thing is one of the Ice Age mysteries here at Interstate Park. Alea, I have to show you something really cool. Now, if you'd been here during the Ice Age, you would have seen ice and it would have melted away. There actually wasn't a lot of evidence left behind by the moving ice of the glacier, not right here at Interstate Park, except for these scratches in the rock. For as that lobe of ice passed over this very hard basalt bedrock, rocks and boulders and other debris trapped in the bottom of the ice scraped and gouged its way into even this very hard rock, leaving behind scratches called striations. Can you see which direction they're pointing?
That way.
They are pointing that way, and that's how we know, and the geologists know for sure, that the ice of the glacier headed over Interstate Park in that direction. Alea, check it out. It's a pothole.
Whoa.
Yeah, this one is about 16 feet deep. It's our deepest pothole. So the first thing you need to know about potholes is that potholes were formed on the bottom of the river.
Oh.
So remember that glacial meltwater I was telling you about? It flowed over all of these rocks. There was so much water and it was moving so quickly that in some places the current of the river caused the water to swirl around, forming a whirlpool.
Oh.
So remember that sand and gravel and other debris picked up by the moving ice of the glacier? Well, now it's being swept along in that meltwater. It gets trapped in the swirling water of the whirlpools. It spins around and around and around, and if that whirlpool stayed in the same spot in the river long enough, that spinning sand and gravel began to act like a liquid drill, and it began to drill into the solid rock below.
Oh, so that's what the swirl on the mural was.
Exactly. Sometimes boulders trapped in the bottom of the glacier would be swept along the bottom of the river, also get trapped in the swirling water of the whirlpools. They would swirl around, and the same sand and gravel that was smoothing out the insides of these holes would also smooth away the rough edges of those boulders until pretty soon they began to look something like that.
Whoa.
That is called a grindstone, or a grinder for short. Scientists gave them that name because they thought the grindstones carved out the potholes, but when they studied it a little bit further, they decided it wasn't just the grindstones, but the sand and the gravel and all of that debris working together with the swirling meltwater to form these steep-sided holes in the rock.
Western Terminus Ice Age Trail. I made it! Those guys have hundreds of miles to go, and I made it!
Hi-ho, down the Ice Age Trail we go. And don't be shy about trekking the Ice Age Trail either. It's good for your body, your mind,
And connects you with the natural landscapes formed by continental glaciers thousands of years ago. Until we see you next time
for another adventure
into the outdoors. Hi-ho, hi-ho, down the Ice Age Trail we go.
Hi-ho, hi-ho, hi-ho.
The following organizations have provided funding for this Into the Outdoors television series.